So we need the magnetosphere. Oh, I'm getting powder all over you, FYI.
Suzanne!
Katrina!
So you're here to do my makeup today.
Yes, I am.
So Suzanne is an amateur makeup artist, but she did our makeup for Beauty and the Beast last fall. So are we going to do Halloween-esque makeup today?
So, no prosthetics.
Ah.
So, but we might be making you look quasi-Lumiere-ish, maybe some glitter. And I was thinking something a little bit more avant-garde and not really work makeup, so like something I would never wear to the office.
I don't have an office anymore anyway. Perfect. Suzanne's also a heliophysics PhD student.
Yes.
Yes.
Yeah.
And so I'm going to be asking you questions about your research and about heliophysics while you're making my face avant-garde and pretty and glittery.
I was about to say, I think this will be fun because I've never played the 20 question games while putting on someone's makeup. So we're going to start off by just priming your lids and stuff like that. So if you want to keep your eyes shut.
Okay. So while you're doing that, what are some of the big questions in heliophysics? What are the major areas of research in that field?
So I can speak specifically to the mission I'm working on and the big questions it's trying to answer. The mission I work on is MMS, magnetospheric multiscale, and it's studying the Earth's magnetosphere where it meets the sun's magnetic field and studying magnetic reconnection. So where the Earth's magnetic field and the sun's magnetic field meet is called the magnetopause, at least on the day side. And those two roughly oppositely facing magnetic field lines, when they go against each other, they do this thing called reconnection, and where they break apart and then reconnect with each other and send plasma and energy and particles down along the magnetic field lines back to the Earth, which cause the aurora. It's that starting point of the aurora. Magnetic reconnection happens at such a small scale that we've never been able to see the moment where the magnetic field lines break and reconnect. And now with MMS, our resolution is fast enough, and we have 4 satellites that are in this mission that...
Formation.
They're in a tetrahedron formation, which is just a pyramid kind of shape, and their distance between them makes it so we can get a 3D representation of the location of magnetic reconnection.
Yeah.
And by the end of the mission, they were hoping to find 16 of these events that we can study. And I think we're in extended mission now, and if I remember correctly, we've already hit that 16.
Okay.
That they're already analyzing and making amazing discoveries on.
Yeah, I did a video on this exact topic, but it was right before MMS launched. So glad to know it's been successful.
Right, yeah. And what's great is I've seen that video, and the people you've just talked with in that video, I've worked with.
It was one of my favorite endings to a video. I said something, blah, 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 and it'll study, we'll finally get answers about magnetic reconnection.
That's probably very fitting. And I wouldn't be surprised if there are people out there that look at what data we're getting now and they're like, wait, so is that reconnection Katrina was talking about? So, okay, I'm going to go in start a little more color here.
Okay. So how exactly does the magnetic reconnection, taking a step back, how is it caused by activity on the sun?
Okay, so when you start at the sun, there's actually a really good video that NASA has put out. I don't know if you had a hand in it at all. And
that visualization that starts at the sun.
Exactly.
And then you see the particles flowing.
Yeah, everyone's seen it. Yeah. It's very well known. But what it is you get solar storms. So you get CMEs or prominences from the sun that spit out the plasma and the energy and change the magnetic field configuration of the sun. And so as that rotational discontinuity, as we call it, in the solar wind moves towards the Earth, that turning in the magnetic field of the sun in combination with the pretty static magnetic field that the Earth gives off, because the Earth is essentially a bipolar magnet in space. It just kind of sits there, always having the exact same magnetic field until it's perturbed by the sun's magnetic field. And so those kind of storms vary in size. We like the most of, since we're in a quiet solar cycle right now, we don't really get anything too exciting. We haven't seen any huge solar storms, like nothing like the October storms we had back in 2003, or heaven forbid the Carrington
Right.
storms from 1856 or whenever it was, 59 or something like that. That would cause a lot more havoc than the storms we're seeing now.
Was it intended for MMS to be in a quiet period of the solar cycle, or is that just how it happened?
I think so. They originally started thinking about, like, the first conception of MMS came back in the early 2000s when, you know, you and I were back in grade school. And at that point, we were in a solar maximum, and since we know the solar cycle, they probably looked at it and were like, it's okay that it's in a minimum. But we just celebrated our 4th anniversary of MMS being launched, and it's showing no signs of slowing down. So maybe it'll last long enough where we can compare the data we're getting here at a solar minimum to data we might be getting in a couple years closer to a solar maximum.
Yeah. Solar cycle is 11 years, right?
Yes.
Is that between maximum and minimum, or between maximum and maximum?
Maximum and maximum.
Okay. So how did you get into heliophysics?
I was really into astronomy. Like, I had the glow-in-the-dark stars. I was trying to do all of the science projects that were, like, astronomy-based. I loved the, like, stories of the constellations. And, like, watching lunar eclipses. And, like, I remember standing outside and watching Hale-Bopp, the comet, go by.
Yeah.
And then my earth science teacher in 9th grade suggested an astronomy camp that I ended up going to 2 summers in a row. And that kind of just, like, kept growing into, like, you know, I'm going to major in astronomy. And so I ended up at a tiny little liberal arts school in Pennsylvania studying astronomy, and then physics, because of course it's not really that much more class to also get the physics degree. So I did that. And then when I went off to graduate school, I knew I wanted to work at Goddard. And so when I started looking for research positions at Goddard, I was talking to someone who did more extragalactic astrophysics, and then I found myself in Building 21 where they had, like, the Heliophysicist, and there was a level of, I understood the local a little more because, you know, it's our local space neighborhood versus, like, galactic nuclei that are many, many light years away. But also there was funding. And as a PhD student, funding is kind of really important.
Okay.
So it's not that I dislike what I do, but there was a large portion of that's where the paycheck was coming from.
Okay. So you came into it through astronomy. Yeah, I doubt there are very many people who, as a kid, are like, I want to be a heliophysicist.
I know, right?
Yeah.
Like, you know, well, actually, so there are people who, like, see the aurora and they're like, I know I want to study the aurora.
Okay.
Like, so that kind of astrophysicist, I can definitely see being a child and growing up wanting to do it. But no 8-year-old, or at least there wasn't an 8-year-old when we were 8-year-olds, that was like, I'm going to study cold ions at the magnetopause. Now, who knows, with this video, they're like, do you want to study cold ions at the Earth's magnetopause? All right. So could you look up for me? Okay. Trying not to poke you in the eye.
Yeah.
Maybe no questions during this part.
Yeah.
I hate being. Sorry, I'm gonna like. I wish I were ambidextrous when it came to makeup.
Well, did you know most astronauts learn to be ambidextrous if they aren't already?
You know, I'm not surprised by that. Yeah, I'm going to do some glitter now.
Okay.
So we're going to use the glitter glue because it always looks better. Don't worry, it will come off eventually.
Eventually.
You have such little eyelids.
I think they're about the size of my eyeball.
You know, probably useful. It'd be really sad if your eyelids were smaller than your eyeballs. All right. So I think I'm going to start doing some of the face, and I'll probably come back to your eye area.
Okay.
So when it comes to foundation, I did want to use something you have and maybe mix it with some stuff I have, depending on.
I have my usual foundation, or I have my stage foundation. So the cream or this liquid, dewy smooth.
Let's do the stage makeup for now, just because we're playing with makeup and I don't want to use the other one. The one eyeshadow palette I was using was Solstice, which was like an astronomy-esque themed one.
A what?
Astronomy-esque.
Oh, astronomy.
Yeah. Like it's got like shade, like the palette's called Solstice, but it's got shades like, this one's more like earth-based. So you've got like winter and twilight and like Helios and rays and stuff like that.
Okay.
But the other one that I have is Supernova, and it's got stuff like Sirius and Nebula and stuff like that in it. So, you know, even my makeup is astronomy themed. I feel like I'm undoing your eyebrows because I'm going to start going over them so I can put like glitter and stuff in them.
That's fine. My eyebrows and eyelashes are usually pretty sparse. Because of my trichotillomania.
What's that word? What?
It's compulsive hair pulling.
Oh,
Yeah.
What is it?
Trichotillomania.
Huh. Is that Latin?
I don't know.
Wait, so I feel like with compulsive hair pulling, why would you pull like the smallest hairs you have? Like, wouldn't it be easier to just pull your regular hair?
Well, some people do, but like those ones are like thick ones. So back to the magnetosphere.
Oh, probably a good idea.
So what day-to-day connections are there besides the aurora? How does it affect people on Earth?
So, without the Earth's magnetic field, we would be constantly bombarded with the magnetic field of the sun. But having our magnetic field as strong as it is, that's what keeps solar storms to more of a minimum, and they're contained at our poles versus like coming all the way down to the mid-Atlantic. So we need the magnetosphere. Oh, I'm getting powder all over you, FYI. We need our magnetic field to protect us and limit those solar storms, because with the electric infrastructure, like all of our power grids, if we didn't have the protection of the magnetic field, we could very easily end up in blackouts all the time.
Probably wouldn't exist at all without the magnetic field.
Probably. But if we were to get a really strong storm that would like knock out our power grids and, you know, shut off our GPS satellites, our cell phone satellites, we would, you know, essentially go back to the age of the Carrington event where there was no electricity. And
well, they had telegraphs and stuff, right?
yeah, they could tell the interference of the magnetic storms through the telegraph systems. Mm-hmm. So I guess MMS doesn't really help on a day-to-day factor, but the data that we are getting from MMS is going to be the way we build up our models, and therefore be able to predict the solar storms that would be, you know, devastating to our power grid and stuff like that. It's going to benefit us in the long run.
Right. How does our magnetosphere compare to other planets' magnetospheres?
So if you learn the science of the Earth's magnetic field, you typically have a pretty good concept of the other planets' magnetic field. So like we have satellites that look at Jupiter's magnetic field and Mercury's magnetic field. And all of those scientists that work on those missions can collaborate fairly easily with the people who work on MMS, because luckily magnetic fields are governed by Maxwell's laws, and so a magnetic field is going to be a magnetic field whether it's surrounding Mercury or Jupiter or Earth. You're going to get some differences because, of course, the strength of Mercury's magnetic field is going to be weaker than the Earth's. And the magnetic field of Jupiter is obviously stronger because Jupiter is such a larger planet. And by the interaction of those magnetic fields for the other planets with the sun's magnetic field is, of course, going to be different, because the sun's magnetic field is going to be different at the different locations. Stronger at Mercury because it's closer to the sun, weaker at Jupiter, and Jupiter has one of its moons has a magnetic field too. So like you kind of have the Jovian magnetosphere, and then I think it's Ganymede, or one of the moons of Jupiter also has its own magnetic field embedded within Jupiter's magnetic field.
Europa, right? Because isn't that one of the lines of evidence for the liquid ocean?
That's possible. I don't know enough about it because I'm not going to try to lie at this point because I don't know that one. Is there anything you want me to talk about while I'm doing this and you can't talk?
Do you want to do heliophysics forever, or would you be interested in shifting to some other area of research at some point?
The future is nigh, and I need to start thinking about what I want to do when I'm done with my PhD. A large portion of what the PhD is, and research in general, is kind of this publish or perish mentality, in the sense that, you need to always be putting out the next paper. And I have found it very difficult to paper write myself. Mm-hmm. I love doing the research. I love looking at a plot, talking with other colleagues about what the science means, and kind of roping it all together. But when it comes to putting pen to paper or fingers to keyboard to write, there's a big disconnect for me. And so I think once I'm done with my research and my PhD, my life will take me outside of the academic community.
Okay.
I'm not sure exactly what that means yet. I've been playing with a couple ideas of applying what I'm learning now to defense, or the statistical knowledge I'm getting to the Census Bureau and stuff outside of science. Maybe I'll feel differently after I get a few more papers under my belt, but where I sit right now, I think my days are numbered when it comes to the research pursuit.
Okay.
Yeah. And I answered all of that without even doing your next eye. And so begins the game of must match them, which means just add more until the entire eye is black.
When did you start getting into makeup?
So when I was in high school, I did a lot of this kind of stuff, that really bright colors, really weird looks, because I was one of those kids that didn't really care what the other kids thought, kind of thing. So I would do like crazy makeup just for the wow factor. And it probably wasn't until undergrad did I realize it wasn't just makeup that I wanted. It was movie makeup that I loved so much. I saw this show Face Off on Sci-Fi that was like a movie makeup competition where they would do like prosthetics and full effects makeup, and I just thought it was the coolest thing. So I'm just as likely to be bloody and gory as I am to be doing something glittery and glammy. Actually, highlighter.
Okay.
Because obviously that is exactly what needs to happen.
I don't think I've ever worn highlighter.
So what's really funny is much like the eyeshadow palettes, the highlighter palette is also astronomy themed. It's the Aurora highlighting palette. So the color I'm about to use on you is called Luna.
Of course, the moon has nothing to do with the aurora.
That's very true. But it also had stuff like Lyra, which is a constellation, Orion, another constellation. It does have Helia, which is sun, and then Eclipse, which you can get a solar eclipse. But yeah, for the most part, it was very, whoever their person was that helped them come up with the names for this palette was not in astrophysics. And actually, there was definitely a part of me at one point that was like, I can consult with makeup companies on their like attempts at being scientific.
Yeah, I don't think they tried very hard.
No. Okay, so I'm going to do a two-tone purple lip on you.
Ooh, nice.
Is it bad that when I put on lipstick on someone else, I like feel like I need to do something with my lips too? Oh, I guess you can't answer me right now.
Yeah, it was like the dentist moment, like,
Right? Alright, more glitter, and then...
more glitter.
Alright, yeah. You have a lot of glitter on your eyes.
Okay.
But I think I'm calling it done.
Okay.
You ready to look at it?
Let me see if I can find that mirror one more time.
You don't want to look at this one? Just...
Oh, okay.
I was about to say.
Okay,
Cool.
cool.
Alright.
Wow. Okay. Wow. I feel like one of the people in the Hunger Games at the Capitol.
Oh, a little bit, yeah.
Okay. And this is the final look.
For me, having no idea where this was going, I like how it turned out.
Let's see. How do I end this? Ta-da! I think it's time for me to eat some dinner.